we have seen it yesterday. This was the exact same project of yesterday. We have used the processing toolbox. We have installed Mappy from the plugin manager. We are not using Mappy today, but this is just for you to remember how the interface is like, and so on. So here we have our impact crater on the far side of the moon, Tsiolkovsky crater. I think we also have Gloria Tognon online, who actually did in practice this map. So this is her work. And for the moment, let me close the map and let's concentrate on the layers. And I would like you, if you can now or later, to download 2 different plugins that I will demonstrate, actually 3 plugins that are used to create topographic profiles, slope profiles, and to color code a profile according to the units that you cross. So to do that, you have to go again to install plugins. So here, manage and install plugins. Open your plugin manager. Oops, it's popping up on another screen. Your plugin manager appears like that. And as you guess, the first one I would like you to install is called Profile Tool. You simply need to type Profile Tool inside the manager. And you recognize it by this greenish icon. You select it. And you get a small description as always, and you click Install Plugin. So Profile Tool is the first one. The second one I would like you to install is called QProf. Okay, QProf. It's also a profile tool, so a tool designed to make topographic profiles, but it's more related to geology, less to simple morphological extraction. So it's also good to build a geologic cross-section, or to, let's say, to gather the basis on which building geologic cross-section when you have a map and topography. And we had a beautiful lesson of last year's school. I suggest you to go and check the videos of last year on how to use this specific tool to create a geologic cross-section. It's not the topic of this year's school, but if you are registered and you have access to the GMAP website, you will have access also to the past year's school, and you will see a beautiful lesson on how to use this plugin. So type QProf, check, and then install. Once it's done, it says your plugin installed successfully. And the last one is called List Coast Path. Actually, it's already installed on my computer, but I cannot install or install it. But anyways, this is another one which is doing something very funny. It's I will demo it as the last part of the lesson, but please install also this one. Okay. Now, we have here lots of layers. We have a Kaguya terrain camera, so a high resolution DTM of Kaguya, a slope map, color coded with different slope thresholds. You see here, I have color coded different slope threshold, one minus than 10 degrees, another from 10 to 15 degrees, and the other one above 15 degrees, as I shown before, what they did on the Schrödinger crater, and for example, around the Shackleton crater. And I have here another DEM, a higher resolution one, sorry, lower resolution one, but wider in scale. So for the moment, let's switch off this one and let's go wider. This is the Tsiolkovsky crater. You see some of the ejector rays, the inner infilling, the peak ring, the central peak, and so on. the first thing we can create using the topography is the hill shade. Hill shade takes the topographic information, takes the topographic information and creates a shaded version according to the source of light orientation. It's much easier to show than to tell. So we can open our processing toolbox here, which stays here on the right. And it's very easy. You have lots of different tools that you can use to process your data. You also have mapping here. As yesterday, you remember to create your map, quick map project setup, etc. Saga GIS, but if you can also search, you can say it's very convenient. I use it all the time, and you can search for hill shade. You have different options.
Riccardo, sorry, can you repeat the third plugin after Profile Tool and cuProf?
List cost path. This one.
Yeah, list cost path.
There is also one embedded in Saga, but it doesn't work on the latest version of QGIS as far as I see. So this is an alternative, let's say. So hill shade. You can do it with the raster terrain analysis of QGIS, or you can use GDAL. I normally use GDAL because it's a bit independent from what happens inside QGIS, and you can also do it by command line if you like. So you simply double-click the function. It should open up, but it didn't. I don't know why. Let me see what's happening. I don't know why it's not happening. It's not opening, but anyways, here it is. It's always opening on my other screen. Sorry for that. So hill shade. The input layer is the DEM, so the topography. Okay, in this case, we will take this one, so Koski DEM, the large scale one. This by number, you can leave it as it is. Z factor is the vertical exaggeration. You will see it in a while. I will leave it 1 for the moment. So the scale is 1:1. Azimuth of the light, meaning the direction from which the light is cast onto the surface in clockwise direction. So 315 degrees means from the northwest. And altitude of the light means the incidence of the light. We can leave everything else as it is. We can save it to a temporary file. It's okay. We can save it later and we can run. Takes a while because the DM is a bit big, but this is the result. Okay, so it's using the topographic information into the DTM to create a shading of the topography. Okay, and you see that the light, in fact, is coming from here. So the shaded areas are here below. But what if, for example, I change the illumination conditions? So, for example, I put it at, like, say, 75 degrees. So coming from southeast. What's happening is exactly, so the input layer is always the DEM, of course, better checking from time to time that the inputs are staying consistent. We can run. And then we have a shading from another direction, from 75 degrees actually, so it's from northeast. You see, if I switch on and off one and the other, you can change the illumination condition. This can dramatically help your mapping, your evaluation of a specific site, and so on and so forth. So hill shade is a very, very good helper in your tasks. Let's say that the standard one is the one from 315 degrees and 45 degrees of altitude. I can also lower the sun or rise the sun inclination if I want. I can show it to you very quickly. And for example, I want the altitude of light very, very low. So it's a good thing to play with, especially if you have a very, very high resolution DTM. It's a good help. We can close. Actually, the new one was created here. This is our new data set. So you see, I have changed the altitude of the sun. Sun is higher, sun is lower. You see that the shadow cast by the central peak here is much more pronounced. Yeah, this is a good start, let's say. Then what we can do? We can remove these layers. I don't want it anymore. We can create our slope map. Okay, we can classify our terrain according to the slope. So as before, I go to my processing toolbox here on the right-hand side, and I can write slope. You are prompted with lots of commands because there are many slight variation of the slope. But let's say I want, let's say, the vanilla one, yeah, the standard one. I double-click slope. I have to be sure to enter as input layer always the DN. That's it. And then we run. Okay, here we have our first slope map. You see that the standard color palette that QGIS is providing to us is a grayscale from 0, which is black, to the highest slope value we have in this map, which is 82 dot something.
Rick, someone is asking to show again the slope map production. It's
very easy. You have to go to the toolbox, check the slope here. You can also use this one, but I use GDAL mostly all the time. Double click, and you simply have to enter the DM, so the topography, not the hill shade, not other things, but the DTM or the topography, and you simply have to click run. It's easy. I can do it again, but if I click run, you simply have the progress bar filling, and then you will end up with this result. If you want to save, of course, your result, when you go to the bottom, it says save to temporary file. This is why this, let's say, ship-like icon is appearing. If you want to save it permanently on your drive, go here, save to file, and then this file is saved into your hard disk and it stays there permanently. If I close the GIS project, this file will be gone. This is temporary, okay? You simply have to scroll down and check for this option. But the input layer must be DN all the time. This is the basic point to start. So you see that now we have our this color scale, which is identifying 0 slope, 0 degrees of slope, so flat areas, basically inside these impact craters, inside Sikorsky, whereas the white areas are the most sloping ones. But we like to make something different. We want to create, let's say, a coding, because we want, for example, to define slope thresholds from something that is trafficable, manageable, something that is risky, something that is impossible to go to because it's too dangerous. So in order to do that, as you remember from yesterday, we have to select our slope map, right-click, the contextual menu opens, we go to Properties, we click on Properties, and then Properties appear, and then you go to Symbology. So I show it again, right-click, Properties, and then you go to Symbology. Here you have your rendering of your slope map, okay? You have single band gray, but you have also other options. We can go to single band pseudo color. This is what we want to do. Not gray, but pseudo color. So this means we can assign our color palette. So we click here. I am prompted with a color palette, but we can choose different ones. If you go here, We can choose different ones. And if you go, these are the most used ones, but if you go here, you get all the color ramps. And you can build your own. Let's say, for the sake of being, let's say, clear, I will use the red, yellow, and green one. Let's say, like a traffic light. Red, go, yellow, careful, red, no go. Okay, so I will select this. Again, I will show you. You have to go single band from gray to pseudo color, and then to color ramp, click on the small arrow, and then go down, all color ramps, and then red, yellow, green, RDILGN. You click, and this appears. And I don't want this because 0 values of slope are red. I want the red to be the dangerous values, okay? So I simply need to invert my color palette. How to do that? You go up here to the color palette. Either you click here and you click invert color ramp. Okay, this way. Or you simply right click, it's the same. And you invert the color ramp. So now we have a coding of 0, the visual slope is green, and then going higher it becomes red. If you click apply, you will see what happens. It's also already a fairly good result. But you see that the slope, color palette is continuous here. I only have 2 values because we have a linear interpolation of all the values. We don't want to have that. We want specific values, and we want to have it discrete. So very, very well defined. So we go here, and we go to exact. Okay. And the mode is equal interval. Okay. So interpolation is exact and equal intervals. And I want, for example, 3 classes. Okay. So go, danger, no go. So we go here and we put 3 classes. Yeah. Either we type or we use the small arrows to go up and down. Yeah. Like that. And you see that the color palette is adjusting according to how widespread it is. Yeah, the more you add, the more subtle is the color nuance between one and the other. We go for 3, so it's green, yellow, and red. And then I can type the value, I think, yes. So 10 degrees, 15, and actually, yeah, it's discrete, sorry, it's not exact, it's discrete values, I'm sorry. 10 degrees, 15, and then more than 15. You see that I have screwed up the whole color bar here. So let's say we will start over. So right click, properties, single band pseudo color. Interpolation is discrete interpolation, not linear but discrete. And equal interval in the mode, and we want 3 classes. And now that I have 3 classes, I can put the value inside. So this is the higher value of the class, so 10. Meaning that this green class is from 10 degrees to 0. Everything below 10. 10 is the maximum value. The yellow class I want to be, for example, 15 degrees, small tolerance, like they put the tolerance they put in the lesson I showed before in the exercise of the Shackleton crater. So I type 15. So yellow is comprising all the values between 10 and 15. And I can leave it as infinite because this is taking into account all the values above 15. Okay. If I click apply, I get this, and then I can click OK. You see, everything is red is above 15 degrees. Okay. Everything that is yellow is between 10 and 15, and everything that is green is basically doable, it's manageable. I can go there. Okay. If we zoom in, this is the central peak. It's immediately clear that we can approach the central peak until at a certain threshold, but we cannot go up the central peak. We cannot cross the central peak. And this is even more striking if, for example, we put the slope map in transparency. If you remember, we have to go to legend, opacity, and then we enable this widget, and then we can adjust the transparency just to have a better idea of the morphology. We can go close to the central peak. We have to be very, very careful of impact craters spread all around, but basically everything coded in green, it's as first approximation, a good place to cross, okay? I will demo it again if you want, but I think that we are running late, so we still have 25 minutes and there's a lot to be shown. So we can show how to create, for example, contour lines, which are also good to detect how steep is an object. Contour lines are the lines that are connecting points on the topography that have the same elevation, okay? We do the same as before. We type contour, and we click here, raster extraction, contour. Double click. Input layer must be all the time the DEM. And then here, something interesting, interval between the contour lines. So how much separation from an elevation and the other I want to have. So let's say that I have quite high values of elevation. So I can put, let's say, for example, 100 meters. This means that every contour line is separated by 100 meters of altitude. And then I can simply click run. And by the way, if an algorithm takes some time to process, you don't have to stay there and wait for it to finish, but you can click close, not cancel, but close. And basically, it runs in the background. You see it here, that the contour lines are executing, but you can still do other tasks. You can still do other things. Everything is going to happen in the background. If you hit close, everything is going down in the background. We can also calculate the aspect. Angelo, do you want to say a few words about the aspect? But basically, the aspect is...
well, essentially, the aspect is where the local topography is facing. For example, if you have a pyramid with 4 sides and you run the aspect, each side of the pyramid will have a color. If the pyramid has, so to say, east-west, north-south orientation. And this color will be the constant because, of course, a pyramid has planar faces, and these faces will just, one will be only facing north, one will be facing east, one south, one west. So you will have 4 colors along these triangles on map. Now, this is not a pyramid, but it's close to it. So you can expect that, for example, the stuff that the part of the central peak which is facing south in the shadow is facing south. So it will be colored south, so to say. The north part is mostly north. And then you have like the left part, which is facing southwest, that probably will be a combination of colors between south and west. So if when Riccardo will run, you will start seeing that at the edge of the flex between one direction and the other, also for curved areas, you will have different colorings. And I think that probably the nicest thing is just to show you, Riccardo, so you can see how it looks like. But in principle, if you don't,
layer is always the DM. And let's pretend that the central peak of Tsiolkovsky is our pyramid. Okay. So basically, we will color code according to the orientation with respect to the north in clockwise direction. So we take the DM as the input file, and everything else we can leave it as it is. We can choose whether to save it or not. Run. If you hit close, you see that it's running here in parallel with the contour lines, just here below. Contour lines are going slow because this is a very, very complex setting, let's say. So this is the aspect. Okay, I have the same problem as before. I have a gray color palette. I don't like it. We can color code it. So right click, properties, symbology, single band pseudo color. And then, for example, we can choose a proper color palette for the aspect, which can be, I don't know, plasma. Again, we want to, for example, to make some thresholds between different angles. Okay.
But the threshold
so
are already very close, do you see?
Yes, these are very close, actually. This is from 0 to 90 degrees, 90, 180, and so on. So we can click apply in this case.
Maybe we can remove the 0. Maybe we can remove either 0 or 360.
Let's do it like that. Let's do the
By the way, there was a request also to show again the scale bar decoration. We can do it also in a while.
But it's a bit out of scope, so.
Yeah, no, I mean, if there is time, we can just show it. I already pointed to the resources. Not now.
Okay. Let me see if it works. I think we can remove this. If you want to remove a class, you simply go there. Okay. So what we did, basically, we have coded according to the orientation. So everything that is blue is from 0 to 90 degrees clockwise, okay? So blue is facing northeast, let's say, from north to east, okay? Purple is from east to south, reddish is from south to west, and yellow is from west to north, okay? So this way, we can have an estimate of the orientation of a surface. And if we know the position of the sun, we can use this information to calculate, for example, whether a place is in sunlight or not, if we can place solar panels, if a place ever goes under the sun or not. So this is a very, very good way to plan also a scientific analysis. This is also used for other reasons, for example, for hydrological purposes, if you want to calculate how a stream goes down to a valley or any type of reason. But this is also good. Let's see if the contour lines are finishing. Sorry, something. Why QGIS? QGIS crashed. Okay, so if you demand too much to QGIS, sometimes it's crashing. Because I was making contour lines inside the whole data set, and probably it was too much. So this can happen anytime. So the lesson learned is save whenever you can. Okay. Okay, let's do it again. So let's create our slope map. Recently used, you see we have a history of what happened. Actually, this is a good function. So if something happens on your computer, you have your processing history here in processing and history, and you can rerun all the commands that you did before. For example, I was calculating the slope, so I can double click and I am prompted on the same window with the same parameters as before. So I can simply hit run, and I don't have to recall what I did, what I did not do. And this history is saved throughout the days with every activity that you do. So it's basically your workflow. If it's well done with not too much try and guess, you can recall all your operations. Right click, I will create my color palette again. Single band pseudo color. I want my red, green, and yellow thing in discrete. I want an equal interval of 3 classes. And I want it to be 10, 15, and higher than 15. And I want my color palette to be reverted. This is, okay, this is not yellow anymore, but I can change it. I can put it yellow with my color wheel. You can change anything you want. You can double click on the color and you can change the color, okay, to your preference. And then you hit here. And actually, this is wrong because I need to type again 10, 15, and then infinite. Now we are back to the same condition as before. I will enable my opacity widget slider. Boom. And now we are happy, almost happy. Okay, aspect. I don't think I need to redo it again. What we can do now is to show finally how to create a topographic profile. And I think I will start with the easiest one, the profile tool. So if you have installed the profile tool, you have this icon here, which is called terrain profile. If you don't have it, or you don't see it because it's cluttered somewhere in your screen, you simply have to go down, up to plugins, and you scroll through your plugins, and you simply select it from here. Okay, so there are multiple ways again to see things. Also because some plugins do not install a button, so they are simply nested inside the plugin menu here. So not all the plugins that provide you interfaces or buttons around, but you have to go here and look for them. So let's say I want to create a terrain profile. I click, and this window opens. Okay, and I want to create a profile. You see that my cursor has become a cross profile throughout the central peak. I want to check the slope and how it looks the central peak. I can click with the left button. I can go up. I can go here. If I double click, I close my profile line. Okay. So here nothing happened because he wants me to select the layer on which he has to calculate the profile. So I have to go down, choose my DTM. You go here, you add your layer. And here you see the topographic profile. Of course, the vertical scale is not respected, but it can be respected. And if you move your cursor on the profile, you will see that on the top, this dot here is following my cursor. Yeah. Here is flat, here is steep. And then you can exactly see what you're looking at. If you have more DTMs, you can add more. I have a higher resolution one, like this one, the Terrain Kaguya DTM, terrain camera. So I can add it, and it's going to be stacked. Here you see this is a gap in the data. But here I can stack 2 different profiles. I can create a new one without gaps, like that. Maybe, no, this has gaps anyways. So let's see, like that. And I can see also if some profiles are matching or not. I can change the color, and these profiles are stacked. You see that these 2 basically are matching almost perfectly. So you can also stack different information all together with this tool, which is very nice. And you can also create profiles along a polyline. You see, the more nodes I'm adding, the more complicated is the profile that I'm getting. Yeah.
Also, one very use case of this is like if you compare different topographic models that you have produced.
Exactly. You can also zoom in and out with your mouse wheel to check. You see, there are places where the profiles are matching or not. I'm checking this place here. You see that the cursor is moving. I am around here, so there's a delta between the altitude of almost 5-6 meters. So this is a good way to analyze your data. Here, for example, we have a very, very large gap of slope. So probably there's some shadows here or some interpolation issues. This is a good way also to check the consistency of your data. For example, here in this region, which is flatter, we have some problems, some gaps. It's not super high, but it's a couple of meters, and maybe we don't want it. So this is a good way also to check. Let's say I also want to plot my slope. Okay, so let's try to do another profile like that. I'm sorry, I'm always encountering these these gaps in data. Okay, this is good. So I don't want my terrain Kaguya DM. I want my slope map. So I can select my slope. I can add the layer. And you can see the slope, which is not really nice, you see, because the slope values are between 0 and 15 degrees. So it's not really good looking. So there's another way to do that, actually. We have again here our topography. Yeah. And you see that here we have a drop-down menu which says height. We can also choose to plot the slope either in percentage or in degrees. If you go here, you click degrees, you get instantly the topographic profile in degrees, and you can interrogate, move your cursor and see the topographic profile. For example, you see here that we are below 10 degrees, and now the slope is changing, and the minus or plus values are because it's oriented on one side or on the other, but it's actually a positive value. And so this is a way to have a quick check at the slope. We can do also other things. For example, we can color code our profile according to our geologic map that Gloria created for us. To do this, we need to use the other tool, the Cuprof tool. By the way, are there any questions or things I need to repeat? I still have to make the contour lines, by the way. I just remember. So I will do it now. Contour, so I can show you another trick. You see, I recently used the contour lines. I want the DM as usual, as input. The interval between the lines I've chosen was like 100 degrees. But it creates the contours along my whole data set. There are ways with other tools to create the contours only within the frame that you're looking at. I think the one of these is here in grass, air.contour. You can take the DM and probably you can set the, I have to adjust the window a bit. You can set the region extent here. Yes. Increment between contour levels. I think we can put 100. If this doesn't work, you got the idea anyways. You can choose calculate from a layer, from layout map, from a bookmark, or to draw it on the canvas extent. We can draw it. So I click here, and then I draw. Oops, what is it? I draw it on my canvas. Doesn't work. Why not? Okay, let's.
Yeah, but the extent is good, no?
Yeah. Okay, that. Draw on canvas. So it's here. I use current map canvas extent. Okay, let's use this. So this is to use what I'm looking at here. The bottom one is to draw my own extent by hand. I think it's okay. We can try to run and see. You see that this grass module, which is another GIS extension inside our QGIS, doesn't have the close button, and actually it does. I have to go here probably. I think I'm asking too much to my computer at the moment. So when you do calculation on DTMs, especially on large areas, you can expect funny behaviors. Okay. Let me try to kill the process and let me see. Okay, I killed the process. We will see contour lines anyways in the next days. You can try on subsets of DTMs. How to color the topographic profile according to a geologic map. For this reason, we will use the other plugin, the QProf plugin. Let me switch off the slope map for a second. And we go here to plugins, we go to QProf. We have an interface opening. I can close my processing toolbox for the moment. And the interface of QProf basically is built up like a workflow. So you cannot go and click a button if you didn't click the button before. So from the top down, you have to do all the steps because it is a workflow. So the first thing you need to do is to define your source DEM. I want this as my source DEM, so my source topography. Then I want, either I digitize a line from scratch now, or I choose a line layer, one of the layers before, to be used as my profile trace on the map. I choose to digitize a line. It says now you can digitize a line on the map. Left click, add point, right click, add ending point. So left click, I add a point, and then right click, ending point. So this is profile line. So these steps are completed. Now I need to read the source data. So I have set this. Now the software needs to read the two in order to start in calculating a profile. Data profile read. Okay. I have to calculate the profile statistics, which are used then to create a plot, which is done very quickly. And then the profile plot. Here we can play with a few parameters. For example, in this case, we can plot together, as in the paper of Bernard of the Shackleton exercise, the height and the slope. We can plot it as filled or empty. Let's say you will see it now. You can choose also how to color your lines. We can leave it in red, and you click OK. So this is our profile in terms of, morphology and the slope, okay? All together. In this case, unfortunately, if you pass your mouse around here, you don't see the tracing of your position from point to point as in the tool before. So every method has its own advantages and downsides. We have to live with it, or we can take the code of this and implement our own improvements if we are used to do that with Python. So this is a good way to plot profiles. We can add another information. We can close this, and we can use the geology. We can plot our polygons, our units. So here we can leave it for a moment. If you want to check what are the functions of these buttons, check last year's school. This is to project the strata aptitudes if you measure some dip and strike information on your DTMs and so on and so forth. But what I want to do here is to color my profile with my polygons. So I have to click to intersect my polygon layer, which is actually this, my geologic units. So I can use my polygon layer. Actually, it prompts me only one because we only have one. Classification field is the type. The type is the name of the unit. If you right click and open the attribute table, you see that the type is the actual unit name, steep scarps, inner slope, etc., etc. Everything you see here in the legend. And then you can define the polygon style. It doesn't take the colors of the polygons automatically. You have to set it manually. there's an easy way to do that. You can go to this button, you can sample the color. By doing this, you click this button, and then you hit the space bar, and it should get the color of your of what you're looking at. But for some reason, this doesn't work. You can sample the color. You go here. For some reason, it doesn't work. Okay, never mind. We will use what we have. Okay. Okay, and then you click intersect. And this is the final result. So see how similar it is with the map of Bernard et al. I will put the PowerPoint here for your convenience in a second, so you can have a look of how similar they can be. So this is the one from Bernard, and this is what we have created. Okay, this is our profile, encountering the infilling of the crater, the central peak unit, again the crater infilling, again the central peak, and the slope profile, staying below 10 degrees until 15 here, and then reaching up to 20 or even more when you arrive to the top of the central peak. And of course, this profile can be saved in many ways. You can export it, you can put it in your paper or whatever you need. If you go here, you can click export as a figure, topographic profile data, etc., etc. You can export it as a figure. I can choose the format and then save it. The downside of this method, apart from not having the dot moving up and down while you move your mouse, is that if you are working with the digitized line, which is a polyline, the method works. I read the source data, I calculate the statistics, everything is fine. I create a topographic profile. I can create again the profile and the slope all together. So I can see a beautiful plot again along this polyline, but the software is not capable at the moment at coloring a polyline with the colors of the geologic units. I am trying to work to an implementation now, but for the moment, what you can do is to either trace only one or trace multiple segments and work every segment separately and then merging them at the end. This is a way to do. Okay, what time is it? I think we are.
I think it's time to wrap up, actually.
Time to wrap up. Okay. I just wanted to show you the least cost path, but we can save it for the G0 exercise. Yes, yes, it's the same. So we will see it on Thursday. You will have time to digest all this information I gave you today. Okay. So wrapping up, you see that the DTM or the DEM is a basics to do a lot of calculations. You can calculate slope, you can calculate the aspect, you can classify the slope according to defined threshold that you can choose. You can define color palettes, you can calculate different profiles along the slope. You can color code the information according to the geologic map, and in the end arrive to an exercise or to a product similar to the one I've shown in the lesson. Everything can be done inside QGIS. There are multiple ways to arrive to the same result, and every method has its upsides and downsides.